Hello, good afternoon to all of you. I hope all of you are doing well. So in today's class, we're going to learn about overloading binary operator. So whenever we are trying to overload binary operator, so it can be overloaded with the help of a member function, or it can be overloaded with the help of a friend function. So whenever you overload a binary operator with the help of a member function, you need to provide one argument. And whenever you are trying to overload a binary operator with the help of friend function, you need to provide two arguments. So that is the basic consideration. So just see here, I have a class complex. Okay, I have two private members, real and imaginary. I have a default constructor here, and I have a parameterized constructor that's capable of constructing the values of of variables x and y. And I have a member function, operator function, that is capable of taking in a complex variable type complex and is capable of returning a variable type complex, and I have a member function display. So now what I have done is I've defined my operator function here to see. So it takes in a variable of type complex. Okay, so here I've declared a variable temp. So to temp.real I've assigned a real plus c dot real, and temp.imaginary I've assigned imaginary plus c dot imaginary, because this real and imaginary will be taken up by the value of another object. So here return temp. So we are returning a complex number. Now I'm displaying the complex number here. Now just see here, I have declared three complex variables, c1, c2, and c3. So I made an explicit call to the constructor. Now just see c1 equals to complex 1 comma 2. This is an explicit call to the constructor, right? c2 is equals to complex 3 comma 4. This is an explicit call to the constructor. So one will be initialized to the real part, and 2 will be initialized to the imaginary part of C1. 3 will be initialized to real part of C2, and 4 will be initialized to imaginary part of C2, right? Okay. Now C3 equals to C1 plus C2. Now the C3 I've called the operator function C1 as operator function plus, that's capable of adding two complex numbers, right? I guess that's C1 and C2, right? So now just see what happens here. Since I've already initialized the object C1 and C2, right? Okay, so C1 will take value 1 comma 2, and C2 will take value 3 comma 4, right? Okay, this is the way how it works. So now C3 is equals to C1 plus C2. So now I'm displaying the results of C1, C2, and C3, or the values of C1, C2, and C3. So this is a very simple program that is capable of adding two complex numbers using constructors, right? Using constructor and overloaded overloaded binary operator using a member function. So now in the next program, what I've done is I've overloaded binary operator with the help of friend function. So the same program, what I've done is I've brought about a manipulation where what we have is we have a friend function, we have the operator function being kept as friend function, and we have two parameters being passed to it. Both are complex numbers, and what I have is I have return value from that particular friend function. So since it's a friend function, I did not specify the class. So I'm passing a and b. So temp dot. So I'm declaring a variable of type temp. So temp dot real is equals to a dot real plus b dot real. Temp dot imaginary equals to a dot imaginary plus b dot imaginary, and return temp. So it will, since the return type is complex, so I'm returning temp. So here this is a simple function for displaying the values of the complex number. So in the main function, I have declared three variables, C1, C2, and C3 of type complex. Then I've made an explicit call to the constructor. The C 10 and 20 will be initialized to real and imaginary part of C1. 30 and 40 will be initialized to real and imaginary part of C2. Then C3 equals C1 plus C2. Then I'm displaying the result of C1, C2, and C3. Now let us move on to function overloading, right? Okay, so function overloading we have discussed in the previous class as well. So here I have two instances of add that's capable of adding two integer values, and add that's capable of adding three integer values. So depending upon how many parameters you pass to add, the respective versions of add will be invoked in order to perform operations. So here in this case I'm passing 10 and 20, so it will call this version of add. Here I'm passing 12, 30, 20 and 23, so it will call this version of add. Right. So this is a very simple way how function overloading works. Now function overloading, here I have again another example of function overloading where we have two functions by the same name, but it differs in data type type and return type. So here I'm calling the necessary function. So whenever 6 and 7 will be provided to the function, it will call this function that's capable of adding multiplying two integer values. So whenever 0.3 and 3 is provided, it will invoke this particular function that's capable of adding two numbers, right? Two numbers that are, one is of type double and the other one is of type integer. Now here, this is a very important program that one needs to understand, that is ambiguity because of type conversion. As you see, here in this particular program, what I have is I have two functions that are capable of taking in float and capable of taking in integer. So this function takes in float, this function takes in integer. Now here I have defined the function that takes an integer, right? Okay, and here I've taken up defined the function that takes in float. So here, whenever I call this function, it will take this particular definition of the function because it takes an integer. But when I call this particular function by passing 1.2, now this particular function should have been called. But in case of C++, what happens is that this 1.2 will be automatically type converted to double. So this I've been discussing in the previous class as well. So any floating point constant will be type converted to double. So if it's type converted to double, then this particular version of the function will not work. So this particular problem is called as the problem of ambiguity because of type conversion, right? Again, so in order to overcome that, what can do is we can have the same function. So I can have function that takes an integer and function that takes in double, right? Again, so you see this is the way how what I've done is I've defined the function. So now the definition of function with the float is being replaced by definition of function by double. So now if I provide 12 and 1.2, this particular program will work because now the parameter of the type of j is double. So now in this particular class, what we learned about is we've learned about overloading binary operator with the help of member function, overloading binary operator with the help of friend function. We have learned about function overloading. We have learned about ambiguity because of type conversion and the mechanism to solve it. Now there might be another solution for this particular problem as well. So in order to, if you want to keep it as float here, right? Okay. So what you can do is you can declare a variable of type float that's initialized with 1.2. So float a is equals to 1.2. Then you can provide a instead of 1.2 here. So in that case also the program will work. So this is the way how you can resolve ambiguity related to type conversion. So thank you very much. Have a very good day.